By December 1943, the Kruger Steel Works in Pennsylvania had delivered their 847th M4A3E8 Easy 8 Sherman tank to the U.S. Army. Meanwhile, across the Atlantic, the Henschel factory in Kassel had just completed their 23rd Tiger II heavy tank for the Wehrmacht. One philosophy emphasized speed, reliability, and overwhelming numbers. The other pursued technological superiority and battlefield dominance through engineering excellence. What happened when these two radically different approaches to armored warfare finally collided would reshape the entire course of the European theater.
Before we jump back in, tell us where you're tuning in from. And if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Lieutenant Colonel Harrison Reed stood in the muddy assembly yard of the Kruger Steel Works, watching the 850th Sherman roll off the production line. The December wind cut through his wool overcoat as he checked his pocket watch. 3 tanks completed since dawn, right on schedule. Reed had spent the last 18 months overseeing production at facilities across the industrial heartland, from Detroit's Chrysler plants to the sprawling factories of Chicago. The numbers were staggering. American industry was producing Sherman tanks at a rate that would have seemed impossible just 2 years earlier. The Sherman emerging from the factory floor looked identical to the hundreds that had preceded it. Same sloped frontal armor, same 75mm M1A1 gun, same reliable Continental radial engine. Reed knew that critics called it mediocre, but he understood something they didn't. The Sherman wasn't designed to be the best tank on the battlefield. It was designed to be good enough and to be everywhere. 3,000 miles away, Oberingenieur Klaus Zimmermann walked through the pristine workshops of Henschel's experimental division. Unlike the organized chaos of American mass production, every movement here was deliberate, precise. Zimmermann paused beside Tiger II prototype number 24, its massive bulk dominating the workshop floor. The tank's frontal armor measured 180 millimeters thick, nearly 3 times that of the American Sherman. Its 88mm KWK-43 gun could penetrate any Allied tank at ranges exceeding 2 kilometers. Zimmermann ran his hand along the tank's perfectly welded seams. Each Tiger II required 300,000 man-hours to complete. At the same time, American factories used to build 15 Shermans. But those 15 Shermans, Zimmermann reasoned, would be scrap metal after encountering a single Tiger II on the battlefield. The philosophical divide between these approaches ran deeper than mere manufacturing statistics. In Washington, General Motors executives met with War Department officials in sterile conference rooms, discussing production quotas and delivery schedules. The conversation focused on logistics, standardization, and supply chains. How quickly could replacement parts reach the front lines? How many mechanics could be trained to maintain the vehicles? How many tanks could be shipped across the Atlantic each month? Meanwhile, in a heavily guarded facility outside Munich, German engineers worked 16-hour days perfecting revolutionary transmission systems and advanced metallurgy. They developed new steel alloys that could withstand unprecedented punishment. They designed optical range-finding systems that allowed gunners to engage targets with precision unmatched by any existing tank. Every component represented the cutting edge of 1940s technology. The cultural differences extended to the men who would operate these machines. American tank crews trained on standardized equipment at bases across the United States. Technical Sergeant William McCarthy had never seen a Sherman tank before arriving at Fort Knox in February 1943. By June, he could field strip the main gun blindfolded and diagnose engine problems by sound alone. The training emphasized adaptability and quick repairs. American doctrine assumed tanks would be damaged, abandoned, and replaced regularly. German panzer crews underwent a completely different preparation process. Unterscharführer Friedrich Weber spent 8 months learning every system on the Tiger II before he was considered qualified to command one. He memorized the ballistic characteristics of different ammunition types, studied the weak points of enemy armor, and practiced engagement scenarios until his responses became instinctual. German doctrine treated each heavy tank as an irreplaceable strategic asset. By spring 1944, these competing philosophies would face their first major test. The Normandy invasion was approaching, and both sides understood that the battles to follow would determine which approach to armored warfare would prove superior. Lieutenant Colonel Reed received new orders in March, transferring him to England to oversee the pre-invasion build-up. The scale of Operation Overlord's armored component amazed even him. Nearly 4,000 tanks would support the initial landings, with thousands more following in subsequent waves. American factories were producing tanks faster than ships could transport them. Reed watched endless convoys of freshly manufactured Shermans rolling onto transport vessels, their olive-drab paint still tacky from the factory. Across the Channel, Oberingenieur Zimmermann worked frantically to accelerate Tiger II production. Intelligence reports suggested the Allied invasion was imminent, but Henschel's factories could only deliver 3 heavy tanks per week. Each machine required specialized components that couldn't be rushed. The transmission alone took skilled craftsmen 2 weeks to assemble properly. Zimmermann knew that dozens of Tiger IIs would face thousands of Allied tanks, but he believed quality would triumph over quantity. The strategic implications of these production decisions extended far beyond individual tank versus tank encounters. American commanders planned their operations around the assumption that replacement vehicles would always be available. If a Sherman battalion lost half its strength in battle, new tanks and crews would arrive within days. This knowledge allowed for aggressive tactics and acceptable loss ratios that would have horrified German planners.
British strategy evolved in the opposite direction. Each Tiger II represented such a significant investment that losing one unnecessarily was considered a tactical disaster. Crews received orders to avoid unnecessary risks, engage only when victory was certain, and withdraw rather than accept unfavorable odds. The psychological pressure on individual tank commanders was enormous. Technical Sergeant McCarthy's crew received their Sherman in late April 1944. The tank bore serial number KS1247, indicating it had rolled off the Kruger Steelworks production line just 6 weeks earlier. McCarthy named the tank Iron Horse and spent the next 3 weeks training with his men in the English countryside. The Sherman felt familiar despite being brand new, identical to the dozens he had trained on back in Kentucky. 300 miles away, Unterscharführer Weber took command of Tiger II No. 47. The massive tank had required 2 months to complete, and Weber was only the second commander deemed qualified to operate it. He spent hours memorizing the tank's specific characteristics. This particular machine's main gun shot slightly high at ranges beyond 1,500 meters, and the port-side drive sprocket had been replaced during factory testing. Every mechanical quirk required individual attention. The contrast between these preparation methods reflected deeper cultural attitudes toward technology and warfare. American industry approached tank production like any other manufacturing challenge: optimize the process, standardize the components, and scale up production to meet demand. The Sherman embodied this philosophy: reliable, maintainable, and produced in overwhelming numbers. German engineering culture viewed each tank as a masterpiece of technical achievement. Every Tiger II incorporated the latest advances in armor design, weapons technology, and mechanical engineering. The tanks were built to dominate any battlefield encounter, regardless of numerical disadvantage. As June approached, both philosophies would face their ultimate test.
The beaches of Normandy awaited, and the coming battles would determine whether technological superiority or industrial might would prevail in the largest armored conflict in human history. The stage was set for a confrontation that would reshape military thinking for generations to come. June 6, 1944. H-hour +3. The first Sherman tanks rolled off the landing craft at Omaha Beach into a nightmare of machine gun fire and artillery. Captain Robert Dalton's M4A1 Thunderbolt churned through the sand, its tracks struggling for purchase on the blood-soaked beach. Behind him, 37 more Shermans from the 741st Tank Battalion pushed inland, their crews operating on pure adrenaline and months of training. Dalton had never seen combat before D-Day. None of his men had. But their Sherman tanks were mechanical extensions of their will, familiar and dependable. When Private Jackson's periscope shattered from sniper fire, he replaced it in 45 seconds without breaking stride. When Sergeant Morrison's radio failed, he switched to backup frequencies his crew had memorized during countless drills in England. American doctrine had prepared them for exactly this.
Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. The Sherman's design philosophy proved its worth in those first brutal hours. When Lieutenant Baker's tank threw a track crossing the seawall, his crew had it repaired and rolling again in 12 minutes using standard field tools. The tank's modular construction meant every component could be swapped quickly under fire. Within 6 hours, 63 Shermans had successfully established positions inland, despite taking heavy casualties during the landing. 60 miles southeast, Unterscharführer Weber received urgent radio orders at his Tiger II position near Villers Bocage. Allied armor had broken through coastal defenses. His heavy tank company, all 4 remaining Tiger IIs in Normandy, would move to intercept. Weber's crew had waited weeks for this moment, but the reality felt different than their theoretical preparations. The Tiger II's massive weight created unexpected problems. Rural French roads, built for farm carts and civilian traffic, crumbled under 68 tons of German armor. Weber's tank had to detour twice around bridges that couldn't support its weight. The advanced transmission system that provided such precise control in training now required constant attention to prevent overheating during extended road marches. By dawn on June 7th, Weber's tank had covered only 14 kilometers in 8 hours of movement. Meanwhile, American replacement Shermans were already streaming off the beaches in endless columns. The 2nd Armored Division alone landed 147 medium tanks during the second wave, with another 89 following before nightfall. Dock workers in Brooklyn had loaded these same tanks onto transport ships just 11 days earlier. The numerical disparity became overwhelming within hours. Captain Dalton's reformed battalion now included tanks from 3 different American divisions, their crews mixed and matched as casualties demanded. The Sherman's standardized design made this improvisation possible. A driver from the 4th Armored could operate any Sherman. A gunner from the 6th Armored could engage targets effectively in any M4 variant. German operations required completely different coordination. Each Tiger II crew trained together for months, understanding their specific vehicle's characteristics and their teammates' reactions under stress. When Obergefreiter Müller was wounded by shell fragments, Weber's tank lost 30% of its combat effectiveness. No replacement crew existed. Training new Tiger II operators took months, not days. The industrial advantages that seemed abstract in planning became brutally concrete in combat. When American tanks were destroyed, replacement vehicles appeared within days. Spare parts arrived regularly through established supply chains. Maintenance crews, trained on identical systems at bases across America, could repair battle damage using interchangeable components stockpiled throughout the beachhead. German logistics operated under completely different constraints. Tiger II spare parts were manufactured at a single facility in Germany, then transported through increasingly dangerous territory as Allied air power dominated European skies. When Weber's tank suffered transmission damage on June 9th, the required components were 400 miles away in a bombed-out factory. Repair would require specialized tools and expertise available only at major depot facilities. Major Dennis Fletcher commanded the American Armored Spearhead driving toward St. Vith. His mixed tank force included Shermans from 6 different production facilities, their serial numbers revealing manufacture dates spanning 8 months. Despite this diversity, every tank responded identically to crew commands. Fletcher's maintenance sergeant could repair any vehicle using the same procedures, the same tools, and the same replacement parts. This standardization enabled tactical flexibility impossible under German doctrine. When Fletcher's lead company lost 7 tanks crossing the Via River, he immediately reorganized his remaining forces. Crews from destroyed Shermans joined tanks with personnel shortages. Drivers became assistant gunners, radio operators became loaders, and the reconstituted force continued advancing within hours. Weber's Tiger II company faced a completely different situation. After 5 days of combat, only 2 heavy tanks remained operational. The other machines hadn't been destroyed in battle. One suffered irreparable transmission failure. Another threw a track that couldn't be repaired without factory equipment. Weber's own tank was running on reserve fuel, and resupply trucks hadn't reached their position in 36 hours. The psychological impact of these contrasting philosophies became apparent as the campaign continued. American tank crews approached combat with calculated aggression, knowing that losses were acceptable if objectives were achieved. Sherman battalions would charge German defensive positions, accepting heavy casualties to maintain momentum. Destroyed tanks would be replaced, wounded crews would be evacuated, and fresh personnel would continue the advance. German heavy tank crews operated under tremendous pressure to preserve their irreplaceable machines. Each engagement required careful calculation. Was the tactical objective worth risking a Tiger II that had required 300,000 man-hours to construct? Weber found himself avoiding battles he might have won, withdrawing from positions that could have been held, because losing his tank would eliminate his unit's combat capability permanently. The Battle of St. Vith illustrated these contrasting approaches. Major Fletcher's task force included 43 Sherman tanks when the engagement began on June 15th. German defenders included Weber's Tiger II and 2 additional heavy tanks positioned in prepared positions. The German vehicles possessed overwhelming firepower advantages and superior armor protection. Fletcher's attack began at dawn with a frontal assault that German doctrine would have considered suicidal. 21 Shermans advanced directly into the Tiger II's engagement zone, accepting devastating casualties to close the range. Within 30 minutes, 14 American tanks were burning wrecks scattered across the wheat fields. But the sacrifice achieved its purpose. The surviving Shermans flanked the German positions while the Tigers focused on the frontal threat.
Weber destroyed 4 American tanks with precise long-range gunnery, but found himself surrounded as more Shermans emerged from concealed positions. His Tiger II could have continued fighting, but German doctrine emphasized preservation of assets. Weber received orders to withdraw rather than risk the irreplaceable heavy tank in a prolonged engagement. The battle ended with German tactical success but strategic failure. Weber's company had destroyed 19 American tanks while losing none of their own. But by the following morning, 26 replacement Shermans had arrived to reinforce Fletcher's task force. Weber's unit remained at reduced strength, waiting for spare parts and reinforcements that might never arrive. American industrial capacity was winning the war through sheer, overwhelming numbers. Every destroyed Sherman would be replaced by 2 more rolling off production lines in Detroit, Chicago, or Philadelphia. Every German tank lost was irreplaceable, representing months of skilled labor and increasingly scarce raw materials. The strategic implications extended beyond individual battles. American commanders could plan operations assuming unlimited equipment availability. German officers faced constant resource constraints that limited tactical options and strategic flexibility. The war of attrition favored the side that could replace losses faster than they accumulated them. August 1944. The Falaise Pocket. Colonel James Whitmore surveyed the burning landscape through his binoculars from the turret of his command Sherman. Hundreds of destroyed German vehicles littered the Norman countryside. Tanks, half-tracks, supply trucks, and artillery pieces twisted into smoking metal sculptures by weeks of relentless Allied air attacks and ground assaults. Whitmore's 3rd Armored Division had spearheaded the encirclement operation, their Sherman battalions racing across France faster than German forces could establish defensive positions. The secret wasn't superior individual tank performance, it was the ability to maintain operational tempo through unlimited replacement capacity. When Whitmore's lead battalion lost 18 tanks breaking through German lines at Argenton, fresh Shermans arrived within 24 hours. The advance never stopped. Inside the shrinking German pocket, Hauptmann Erich Hoffmann commanded the remnants of 3 different panzer companies consolidated into a single composite unit. His surviving Tiger II had mechanical problems that would normally require depot-level maintenance, but field repairs kept the massive tank running on determination and improvised solutions. Hoffmann's crew had been eating emergency rations for 6 days. Supply convoys could no longer penetrate the Allied encirclement. The contrast in supply situations was stark beyond comprehension. American logistics units delivered 1,400 tons of ammunition, fuel, and spare parts daily to Whitmore's division alone. Replacement tanks arrived on specially designed heavy transporters, their crews already trained and ready for immediate deployment. Mobile maintenance units could rebuild damaged Shermans using interchangeable components stockpiled throughout the advance. Hoffmann's men scavenged ammunition from destroyed vehicles and siphoned fuel from abandoned trucks. His Tiger II's main gun had 17 armor-piercing rounds remaining. Each shell represented a tactical decision that could determine his crew's survival. German doctrine emphasized ammunition conservation, but conservation became meaningless when no resupply existed. The mechanical reliability differences became critical during extended operations. Sherman tanks were designed for constant movement and field maintenance. Technical Sergeant Anthony Martinez could diagnose most problems by sound alone after 8 months of combat experience. His toolkit included standardized wrenches, replacement parts, and diagnostic procedures that worked on any M4 variant. When his tank's final drive started making unusual noises near Chambois, Martinez identified the problem and completed repairs in 40 minutes without leaving the battlefield. Hoffmann's Tiger II suffered from a completely different mechanical philosophy. The tank's sophisticated systems required specialized knowledge and precision tools. When the transmission developed shifting problems on August 18th, Hoffmann knew the proper repair required factory-level expertise unavailable in the field. His crew improvised a temporary solution using salvaged parts, but the tank's mobility was permanently compromised. American tank crews adapted to combat conditions through practical experience rather than theoretical training. Staff Sergeant Paul Henderson had destroyed 11 German vehicles during the Normandy breakout, learning enemy weak points through direct engagement.
His Sherman's 75mm gun couldn't penetrate Tiger II frontal armor, but Henderson had discovered that tracks, drive sprockets, and vision ports remained vulnerable to precisely aimed shots. Henderson's tactical knowledge spread quickly through informal networks. American crews shared combat experiences during maintenance breaks, meal times, and equipment exchanges. When Henderson demonstrated his track targeting technique to Lieutenant Coleman's platoon, 5 more Sherman crews adopted the tactic within hours. This rapid information dissemination multiplied individual innovations across entire armored divisions. German heavy tank tactics evolved more slowly due to limited crew interaction and formal command structures. Weber's successful engagement techniques at St. Vith never reached other Tiger II commanders because battlefield communications had broken down. Each crew developed individual solutions to tactical problems, but institutional learning occurred only through official channels that no longer functioned effectively. The strategic situation deteriorated rapidly for German forces throughout August. Allied codebreakers had intercepted Wehrmacht communications, revealing desperate shortages of fuel, ammunition, and replacement personnel. German tank commanders received orders to abandon damaged vehicles rather than attempt repairs that required unavailable parts or expertise.
Whitmore's intelligence officers tracked these developments through captured documents and prisoner interrogations. German panzer strength had dropped from 127 operational tanks in June to 31 serviceable vehicles by late August. Meanwhile, American armored forces in Normandy had grown from 800 tanks during the initial landings to over 2,100 operational Shermans, supported by unlimited replacement capacity. The Battle of Chambord demonstrated these strategic realities in microcosm. Lieutenant Colonel Samuel Foster's tank battalion encountered Hoffmann's composite German unit during the final phase of the encirclement operation. Foster commanded 37 Sherman tanks supported by artillery, close air support, and immediate reinforcement availability. Hoffmann led 9 operational German vehicles of various types, including his damaged Tiger II. The engagement began with German advantages: superior individual tank performance, excellent defensive positions, and experienced crews. Hoffmann's Tiger II destroyed 3 American tanks with long-range precision fire before Foster's Shermans could close to effective engagement range. But tactical success couldn't overcome strategic mathematics. Foster's battalion absorbed casualties that would have crippled German units while maintaining offensive momentum. When direct assault proved costly, Foster called for artillery support that arrived within minutes. When German positions proved too strong for frontal attack, Foster requested airstrikes that materialized overhead before the radio conversation ended. American doctrine emphasized using all available assets rather than relying solely on tank versus tank combat. Hoffmann watched helplessly as overwhelming Allied firepower systematically destroyed his defensive positions. His Tiger II's thick armor provided protection against Sherman guns, but offered no defense against rocket-armed fighter bombers, heavy artillery, or the coordinated combined arms tactics that American forces had perfected through months of combat experience. The psychological pressure on individual German tank commanders had become unbearable. Hoffmann knew that losing his Tiger II would eliminate his unit's only effective anti-tank capability, but continuing to fight meant certain destruction against impossible odds. German doctrine provided no guidance for situations where tactical withdrawal was impossible and strategic victory was unattainable. Foster's Sherman crews approached the same battle with completely different mindsets. Individual tank loss was regrettable but acceptable if the unit achieved its objectives. Replacement vehicles, crews, and equipment would arrive automatically through established logistics networks. American tank commanders could focus on tactical execution rather than equipment preservation. The final phase of the Falaise encirclement revealed the ultimate consequences of competing production philosophies. German forces lost approximately 1,500 armored vehicles during the pocket battles, tanks, assault guns, self-propelled artillery, and support vehicles, representing years of specialized manufacturing effort. These losses were irreplaceable given Germany's collapsing industrial capacity and raw material shortages. American losses during the same period totaled 347 Sherman tanks and 89 other armored vehicles. Within 2 weeks, replacement production had not only made good these losses, but had actually increased total American armor strength in France. The industrial war of attrition was reaching its inevitable conclusion. Hoffmann's Tiger II was abandoned near Trun on August 20th when the transmission finally failed completely. The massive tank had survived dozens of combat engagements and destroyed 23 Allied vehicles during its brief combat career. But mechanical complexity and irreparable battle damage had ended its effectiveness more decisively than any enemy action. The abandoned Tiger II represented everything wrong with German armored warfare philosophy. Technological sophistication meant nothing without sustainable production, adequate supply chains, and replacement capability. The most advanced tank in the world became worthless scrap metal when it could no longer move or fight. October 1944. The Siegfried Line. Brigadier General Thomas Crawford crouched in his forward command post, studying intelligence reports that painted a grim picture of German defensive preparations. The Wehrmacht had withdrawn behind the Reich's western fortifications, using the rest to reorganize their shattered armored forces. But the numbers told a story that no amount of tactical brilliance could overcome. Crawford's armored corps now fielded 1,847 operational Sherman tanks across 4 divisions. Behind them, Atlantic convoy schedules promised another 312 replacement vehicles within the month. American tank production had reached peak efficiency. Factories in Cleveland, Detroit, and Oakland were completing new Shermans every 18 minutes around the clock. The industrial machine that had seemed impossible in 1941 was now unstoppable reality. Deep inside the Reich, General Major Klaus Brenner surveyed his remaining panzer assets with growing desperation. 31 operational tanks comprised his entire armored reserve, a mixture of battle-worn Panthers, obsolete Panzer IVs, and 5 precious Tiger IIs that had survived the Normandy catastrophe. German tank production had collapsed to fewer than 40 vehicles monthly as Allied bombing devastated manufacturing centers and raw materials became unobtainable.
The technological gulf between German and American approaches had narrowed dramatically through combat experience. American ordnance engineers had developed the 76mm M1A1 specifically to counter German heavy armor. The new weapon, mounted in upgraded Sherman variants, could penetrate Tiger II side armor at combat ranges. More importantly, American factories were installing these improved guns on hundreds of tanks monthly. Captain Roy Mitchell commanded one of the first M4A3E8 Easy 8 Shermans to reach the European theater. His tank featured the new 76mm gun, improved armor protection, and enhanced suspension systems that incorporated lessons learned from 8 months of intensive combat. Mitchell's crew had trained on the upgraded Sherman for only 3 weeks, but the familiar controls and procedures made adaptation effortless. German technological development had stagnated completely. The Tiger II remained mechanically identical to machines produced 18 months earlier because retooling production lines was impossible under constant air attack. Worse, quality control had deteriorated as experienced factory workers were conscripted for military service. Newer German tanks suffered from substandard metallurgy, improper heat treatment, and assembly defects that would have been unthinkable in 1943. Oberst Heinrich Müller commanded the last intact Tiger II company in the Western Theater. His 4 remaining tanks represented the absolute pinnacle of German armored technology, but mechanical problems plagued every vehicle. Transmission failures, final drive breakdowns, and electrical malfunctions occurred with increasing frequency. Müller's maintenance crews performed miracles keeping the tanks operational, but spare parts existed only through cannibalization of abandoned vehicles. The Battle of Aachen revealed how completely the strategic situation had reversed. Crawford's armored spearhead included 156 Sherman tanks supported by unlimited artillery, close air support, and engineer assets. American forces could afford to accept heavy casualties because replacement capacity guaranteed continued offensive operations regardless of tactical setbacks. Müller's Panzer Group defended critical approaches to the city with desperate efficiency. His Tiger IIs occupied prepared positions that maximized their firepower advantages while minimizing exposure to Allied artillery and air attacks. German defensive doctrine had evolved into a careful balance between inflicting maximum casualties and preserving irreplaceable equipment for subsequent battles. The engagement demonstrated American tactical evolution under fire. Major Vincent Riley's Sherman Battalion no longer attempted costly frontal assaults against prepared German positions. Instead, Riley coordinated complex combined arms operations that used artillery suppression, smoke screens, and infantry cooperation to neutralize German advantages before tank engagement began. American crews had learned to exploit German psychological vulnerabilities. Staff Sergeant Douglas Clark discovered that aggressive maneuvering forced German commanders into defensive reactions that limited their tactical options. By threatening multiple approach routes simultaneously, American tanks could force German crews to abandon superior positions rather than risk encirclement. Müller's defenders faced impossible tactical mathematics. Each successful engagement depleted ammunition stocks that couldn't be replenished. Every mechanical breakdown reduced combat strength permanently. German tank commanders found themselves avoiding battles they could win because victory itself consumed resources faster than defeat would have. The industrial advantages that seemed abstract in planning had become brutally concrete in execution. American replacement crews arrived with standardized training that made them immediately effective in combat. German replacement personnel, when they existed at all, required weeks of specialized instruction before achieving minimal competency on complex vehicle systems. Technical innovation continued driving American advantages. The Sherman EZ-8 incorporated battlefield lessons into improved designs that reached combat units within months of identification. Improved armor schemes, better ammunition, and enhanced crew protection reflected direct feedback from frontline commanders. American tanks were evolving constantly through systematic analysis of combat performance. German innovation had ceased completely. The Tiger II design remained frozen because any modifications would disrupt the already minimal production capacity. Quality problems multiplied as strategic materials became unavailable. Synthetic rubber deteriorated rapidly, electrical systems failed unpredictably, and armor steel contained impurities that created weak spots vulnerable to standard American ammunition. Captain Alan Harding's maintenance company epitomized American logistical superiority. His mobile repair units could completely rebuild destroyed Shermans using stockpiled components transported from supply depots hundreds of miles behind the front lines. Battle-damaged tanks returned to combat within days, often incorporating improvements that made them more effective than original factory specifications. Müller's maintenance situation had become desperate beyond imagination. His workshops operated without electricity, adequate tools, or replacement parts. Skilled technicians performed complex repairs using improvised equipment and salvaged materials. German tank crews learned to conduct field maintenance that would normally require factory-level expertise, but such measures provided only temporary solutions to permanent problems. The psychological impact on individual tank crews reflected these broader strategic realities. American Sherman crews approached each engagement knowing that their industrial base guaranteed continued support regardless of immediate tactical outcomes. Equipment losses were regrettable but acceptable if mission objectives were achieved. Crew casualties would be replaced, damaged tanks would be repaired or replaced, and offensive operations would continue. German tank crews operated under crushing psychological pressure that affected combat performance. Every engagement potentially eliminated irreplaceable equipment and experienced personnel. Tactical decisions required constant calculation of resource expenditure versus strategic value. The knowledge that losses couldn't be replaced created defensive mindsets that limited offensive capabilities. The Battle of Schmidt illustrated these contrasting approaches under extreme conditions. Crawford's armored task force included 93 Sherman tanks attacking German positions defended by Müller's remaining Tiger IIs and supporting armor. American doctrine emphasized rapid advance and acceptable casualties to maintain offensive momentum.
British defensive plans relied on precise coordination between limited assets to achieve maximum tactical effect. Müller positioned his Tiger IIs to create interlocking fields of fire that would channel American attacks into predetermined killing zones. The defensive scheme was tactically brilliant but strategically hopeless. Success merely delayed inevitable defeat while consuming irreplaceable resources. The battle lasted 4 days and ended with complete American victory, despite heavy initial casualties. Crawford's forces lost 37 Sherman tanks, but achieved all tactical objectives. Replacement vehicles arrived before the offensive resumed, and damaged tanks returned to service after rapid field repairs. American operational capacity remained undiminished. Müller's Panzer Group ceased to exist as an effective fighting force. 2 Tiger IIs were destroyed by concentrated fire, 1 suffered irreparable mechanical failure, and the 4th was abandoned when fuel supplies were exhausted. German resistance in the sector collapsed completely, opening approaches to the Rhine River that could never be closed again. March 1945. The Rhine Crossing. General Alexander Stone stood on the eastern bank of the Rhine River, watching an endless procession of Sherman tanks rolling across the pontoon bridges his engineers had constructed in less than 18 hours. Behind him, the industrial might of America continued its relentless advance into the heart of the Third Reich. The numbers had become almost meaningless. 2,847 operational tanks in his army group alone, with replacement schedules that guaranteed numerical superiority would only increase. Stone reflected on the transformation that had occurred since D-Day. American armored doctrine had evolved from theoretical concepts into battle-tested reality through constant adaptation and unlimited resources. Sherman crews now possessed combat experience that made them the equal of any tank force in history. More importantly, they operated within a system that treated individual losses as acceptable costs rather than catastrophic failures. In a concrete bunker 50 miles east of the Rhine, Oberst Friedrich Wagner commanded the last organized German armored resistance in the Western Theater. His unit existed only on paper, 7 operational tanks scattered across a front that should have required 3 full divisions to defend adequately. Wagner's men had been fighting continuously for 9 months, sustained only by determination and increasingly desperate orders from high command. The final German tanks represented an ironic culmination of their original design philosophy. Each remaining Tiger II embodied thousands of hours of precision engineering and advanced metallurgy. The vehicles were technological marvels that could destroy any opponent in single combat. But individual excellence meant nothing against an enemy that fielded hundreds of competent tanks supported by unlimited industrial capacity. Lieutenant Colonel Richard Barnes commanded the spearhead elements of the American advance across central Germany. His tank regiment included Shermans manufactured in 7 different states. Their production dates continuous factory output. Despite this diversity, every vehicle responded identically to crew commands and could be maintained using standard procedures and interchangeable parts. Barnes had personally witnessed the evolution of American tank warfare from the bloody lessons of Normandy to the systematic destruction of German resistance. His crews no longer feared individual Tiger tanks because overwhelming numerical superiority guaranteed tactical success regardless of local setbacks. American doctrine had become a machine for converting industrial output into battlefield victory. The contrast with German operations was now absolute. Wagner's scattered tanks operated independently because coordinated movement was impossible without fuel, spare parts, or reliable communications. Each crew made individual tactical decisions based on local conditions rather than overall strategic objectives. German armored warfare had devolved into isolated last stands by determined but doomed defenders. Major Charles Sullivan's Sherman battalion encountered Wagner's final Tiger II position near Kassel on March 29th. The engagement epitomized everything that had changed since 1944. Sullivan commanded 41 operational tanks supported by artillery, close air support, and immediate reinforcement availability. The single German tank, despite its technological superiority, represented no meaningful threat to American operational objectives. The crew fought with desperate skill, destroying 6 Sherman tanks before concentrated return fire penetrated their armor. But tactical success was strategically meaningless. Sullivan's battalion continued advancing, while replacement tanks arrived within hours. The German crew's sacrifice accomplished nothing against a brief delay of an inevitable outcome. American tank production had reached levels that seemed impossible just 3 years earlier. Factories across the industrial heartland were completing new Shermans faster than shipping could transport them to Europe. The Kruger Steelworks alone had delivered 4,247 medium tanks since production began in 1942. Similar facilities in Detroit, Chicago, Pittsburgh, and Oakland had contributed thousands more vehicles to an arsenal that dwarfed any previous military mobilization. German tank production had ceased entirely in most regions as Allied bombing and advancing ground forces overran manufacturing centers. The few remaining factories operated sporadically when power was available and raw materials could be obtained. Quality control had become non-existent. Tanks rolled off production lines with defects that would disable them within days of reaching combat units. Technical Sergeant Marcus Thompson epitomized the American advantage in human resources. Thompson had trained 3 different Sherman crews during his 18 months of combat service, transferring hard-won experience to replacement personnel who arrived regularly from training centers in the United States. His knowledge of German tactics, terrain analysis, and combat maintenance had multiplied through informal networks until entire armored divisions benefited from individual innovations.
British tank crews possessed no equivalent system for institutional learning. Combat veterans like Wagner operated in isolation, their tactical expertise dying with them when their tanks were finally destroyed. The Wehrmacht's rigid command structure had prevented the horizontal sharing of battlefield knowledge that gave American forces such adaptive advantages. The final phase of the war revealed the ultimate consequences of competing production philosophies that had seemed theoretical in 1943.
American commanders planned operations assuming unlimited equipment availability and acceptable loss ratios. German officers faced constant resource constraints that made any sustained offensive action impossible. Colonel Patricia Morrison's Armored Task Force exemplified American operational freedom. Her unit included 127 Sherman tanks, self-propelled artillery, armored infantry, and engineer assets that could overcome any defensive position through concentrated firepower and tactical flexibility. Morrison could afford to accept heavy casualties because strategic objectives mattered more than equipment preservation. German defensive operations had become exercises in resource management rather than tactical excellence. Wagner's remaining tank commanders hoarded ammunition, avoided unnecessary movement to conserve fuel, and withdrew from positions they could have held, because losing irreplaceable equipment served no strategic purpose. The Battle of Frankfurt demonstrated these realities in their starkest form. Morrison's task force attacked German positions defended by Wagner's composite regiment, now reduced to 3 operational tanks and supporting infantry equipped with obsolete anti-tank weapons. American forces could have overwhelmed the defenses through direct assault, but Morrison chose systematic destruction through artillery and airstrikes that eliminated German resistance without risking unnecessary American casualties. Wagner watched helplessly as overwhelming Allied firepower systematically destroyed his defensive positions. His remaining Tiger II could have engaged American tanks with reasonable prospects of tactical success, but victory would only delay defeat while consuming irreplaceable ammunition. German doctrine provided no guidance for situations where tactical excellence was strategically meaningless. The symbolic end came on April 15th when Wagner's last Tiger II was abandoned due to mechanical failure rather than enemy action. The massive tank's transmission had finally succumbed to months of emergency repairs and improvised maintenance. The crew escaped on foot, leaving behind the most advanced tank design of the war, reduced to immobile scrap metal by its own complexity. American Sherman tanks continued their advance across Germany, supported by logistics networks that had become the true weapon of Allied victory. Industrial capacity, standardized production, and unlimited replacement capability had proven more decisive than individual technological superiority. The war had become a contest between competing philosophies of military production, and quantity had triumphed over quality through systematic application of overwhelming resources. General Stone received Germany's surrender while standing beside his command Sherman in a Berlin suburb. Around him, hundreds of American tanks represented the culmination of the greatest industrial mobilization in human history. The final irony was complete. German engineers had created the world's most advanced tanks, but American factories had built the machines that won the war. The lesson was clear and unforgiving. In modern industrial warfare, the side that could produce adequate equipment in overwhelming quantities would always defeat opponents who pursued technological perfection at the expense of mass production. The Sherman tank, dismissed by critics as mediocre, had proven that reliable competence multiplied by unlimited numbers was the formula for ultimate victory. Germany had built 1,347 Tiger tanks that represented the pinnacle of armored technology. America had mass-produced 49,234 Sherman tanks that had crushed the Wehrmacht through sheer overwhelming superiority. The contest between quality and quantity was over, and quantity had won decisively. General Stone received Germany's surrender while standing beside his command Sherman in a Berlin suburb. Around him, hundreds of American tanks represented the culmination of the greatest industrial mobilization in human history. The final irony was complete. German engineers had created the world's most advanced tanks, but American factories had built the machines that won the war. Up next, you've got 2 more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.